Okay, so we finally are beginning vectors, the second part to calculus and vectors. We finished chapter 5, which concludes all of calculus. Now we're going to start with vectors. A lot of you have probably already used vectors in physics or science. So let's get started. So what is a vector? So let's say I draw a line like this with an arrow. I can call one point of this A and one point of this B. Just some labeling. Let's say I call this is a vector. This is vector AB. This is the tail, and this is the head. Now, two things to consider. Vectors have two things. One, this is direction. So this arrow is saying it's going this direction. That's one of the things it has. So we see that in our illustration with the arrow. And the second thing it has is a magnitude. And in this case, it's the length of that line segment. If we don't have two things, direction and magnitude, we don't have a vector. So it's very important to consider magnitude and direction, and we use absolute notation for magnitude because let's say you're going 100 kilometers an hour this way. 100 kilometers an hour this way would be negative. We're really only interested in the 100 kilometers an hour. The negatives tells us the direction, but the magnitude, we're just going to say everything is positive because it makes more sense. Okay, so get another color. So just a quick example. I'm going to speak on velocity. So driving 100 kilometers per hour is something called scalar, because we're taking a speed and we're multiplying it by a larger number, going to 100, and we're scaling it higher than the 1. Okay, so 100 is scalar because it is only a scale of another number. There's not two different things involved. Okay, so this is speed. But driving 100 kilometers per hour north is a vector. Very, very simple difference. One is just, one could dictate speed and one is velocity. So the difference between speed and velocity, if I drive in a circle like this, I could have speed, but my velocity is 0 because I'm ending up in the same spot I started. I'm sure you got into it in physics, but speed is scalar, but velocity is a vector because we have that direction piece. Okay, now equal vectors and opposite vectors. So how do we know a vector is the same as another vector? So equal vectors always are parallel, which means they have the same direction. Another thing, they have to have the same magnitude. So for instance, if I have this vector is going in this direction, it has to be not only parallel to this line, it has to have the same magnitude, which means the same length, the exact same length for these vectors to be equal, obviously. Opposite vectors are parallel, they have the same, actually I'm going to put it over here, this is opposite direction. But they also have the same magnitude. So for instance, I have a vector like this. Here's my parallel vector, and if I put the arrow this way, I'm going to have an equal vector. However, I'm going to put the vector this way. These are opposite vectors. For instance, if I add these two, I get 0. Whereas if I add these two, I get 2 of whatever the magnitude is. So if this is 4, together it's 8. if this is 4, this is -4, together this is 0. So I mean, it makes sense, but now we're going to use vectors just to analyze the simple math that we've been doing since grade 9. It's going to get a little more complicated, but this is pretty much it. The last thing I want to say is we could also, let's say this is vector AB. We can call this vector AB with an arrow on top, absolute value. We could also call it vector V. Okay, this is just two pieces of notation that I can use to represent this vector. I'm going to be using both, but it's easier just to use one letter. Obviously, it's much less writing. Okay, and I can call this one U, for instance. And I can say U plus V equals 0 in this case. Okay, so equal vectors and opposite vectors are pretty straightforward. And that's pretty much it for just what vectors are. Until we get into adding and multiplying them, subtracting them, whatever the case may be, there's not much really to consider, so get it all done in 6.1 and brace yourself for the rest of this chapter.